Hello, and welcome back to Learning with Lee. In today's episode, we are going to take a look at how to insert one string into another string. And there's quite a few different variants on this. The functions and methods for this have been overloaded numerous times to take in practically any arguments you can imagine. So I'm going to cover the bulk of the different ones of these, though I'm not in general, such as you'll see in here, how I have insert here, append here, and replace down here. These all basically have the same different variations on overloading. So if you see something like this here, it's safe to assume that there's a similar thing for append that allows you to, in this case here, take a substring of the second string you pass in. Or similar to how in here I happen to be appending 5 exclamation points. But we'll get into exactly what each of these overloads does. But it's important to remember that basically insert, append, and replace all have fairly equivalent overloaded functions, so as that you can use them in pretty much any way you can think of. So to begin with, for our strings, and once again this is just C++ style strings, you can insert at really any spot in that string. So if I want to insert at, in this case here I want to say this is not a test string rather than this is a test string, I can begin by inserting after this, basically after is, or alternatively I could do it after this space, but it would modify where I would have to put in this space here. So in this case here, I'm just putting in the string not, and then I'm putting in a character pointer space. And really this would be the same as if I had just done that, and same thing for s not here, I could also just as easily replace that like this, and any one of those end up working, they're valid, they happen to be different variants that you can end up doing with them. So there is an important thing to note, though, about these two inserts here, where it inserts not in space. It's modifying the original string. This does end up returning a string, but it basically returns itself. And that's so as you can do things like what I'm doing here, where I'm outputting it after doing the insert. And we'll see that with not every single function that we do does it necessarily modify that same string, and that also is language dependent. Because in Java, and not to get too much into Java, but in Java, strings are immutable, meaning that you can't directly modify them. Basically, if you want to, you get a brand new string when you try to modify it. So in this case here, insert wouldn't actually modify stest. It would create a brand new string and return that then, which you could then use. So it's important to note that this is different than that for those of you who might have more experience with Java, that you are in fact modifying the original copy stest here. The other thing is that for a lot of this counting, what you have to understand is that this first number for where you're inserting is the index where you want to be. And since it's zero-based, the quickest and easiest way to do this count is to go, okay, how many characters do I have here? Well, there's 4 letters in this, 2 letters in is, and a space, so 7 characters. So you just use 7 there, because effectively that's giving you this index where currently this space is. And you can see down here that it's modifying it. You can see down here that it does retain it. However, the reason why not gets put right there is because of the fact that that is the 7th, well, technically it's the 8th element in there, but it's, in case we were to subscript this and do stest sub 7, such as up here, stest sub 7, that would be the character we would get out. We would get out this space. So that happens to be why all of this ends up taking place as it does. Then, down here, let's say that we wanted to convert from that's a moon to that's no moon, as in we were going to follow it up with that's a space station. So what we would want to do then is we'd want to add in a space. In this case here, because I put the space before I put in the other thing, I then have to go one further character on. Because otherwise what I would wind up with is, because right now you can see down here we have these 2 spaces, if I just left this number at 6, what would end up happening is that then we would get this no here put before this space here, and we would still have these 2 spaces, but the s and the no n would be running into each other. So that's really not what we need to do, so that is an important thing to remember when you do insert something into there. In case you're going to want to insert after it, you have to add in the length of the string or the character array or whatever else that you're inserting in there. However, the important thing about this one is I'm able to take a substring of s naught. So in this case here, I only want no, I don't want not. So I only want to start at the first character, so 0. so index 0, and I want the first 2 characters. And this is similar to what we did with comparing up in this function up here, and it happens to be, in general, a fairly common thing that you'll see for all of these ones is that they have these overloads. So that's another one that I just end up getting out no and inserting it into there. Then you can also append, and we already went over this a little bit earlier on when we went into assignment where we did this plus equals operator down here, and that effectively does appending. However, it happens to also have a function or a method for doing appending for us. So we can use this method in order to append on strings. We can append on, in case we want to, just characters, so both C and C++ style strings, as well as then we can also then append on multiple characters. So if you look down here, this is saying I want to append on this character 5 times. So basically what it's doing is that's reallocating the memory or allocating some new memory, depending on how string itself is specifically implemented on your system and how its underlying logic is. But basically it's getting the additional memory it needs for these characters, saying, okay, we need to put that at the end of our current string, and then it's just doing a mem set in order to set it equal to this here. And this just is telling it how much memory it actually needs, effectively. So that allows us to do things such as insert multiple characters there, and it can be done at any location if you really want to. Because, well, in this case here it's appending, but you can also do insert doing this exact same thing. So if for whatever reason I want to say insert a certain number of, let's just leave that alone, and let's just go with then I want to insert 2 hyphens, so that and that. You can see that that's not giving me any errors. That is actually something that I can do if I want to insert a double hyphen there for whatever reason. I don't want to, so we're just going to get rid of that. But that happens to be another possible thing that we can actually look at and do. So that's another one to be aware of. It's not as common to use as these other versions of append and insert are, but it does exist, and occasionally it is the correct tool for the job that you're looking to do. Then you can also replace. So similar to inserting, the important thing about inserting is that you're never actually, and you can see that in these examples up in here and up here, as well as then to a lesser extent with appending. It makes a bit more sense with appending that you aren't actually replacing the characters. But with insert, you end up leaving the original string alone. You end up just adding in additional information. You don't delete any information. Well, with replace, and replace once again has many of these same different variants up here, but they tend to be over in this side of the argument. The first 2 tend to almost always be, what character do you want to start with, and how many characters do you want to replace in this original string? So in this case here, now I can actually do that's no moon correctly, because previously, when I ended up doing that insert, because of the fact it didn't delete this space A here, that left us with a problem. So now I can replace effectively this no space A with the word no, provided that I once again take the substring of S naught. Alternatively, I can also replace characters using sort of this literal string here, in which I already happen to have it defined within there and it's constant. Or I could do it with a character pointer or any of these other varieties I've already shown up in here. So there is also one other thing I could do, and that's that I could replace it with an empty string. And it's important to think about this not as though it happened to be a bunch of null terminating characters that are getting added on. What you have to really think about it as is that it's looking at, okay, I'm going to be removing a certain number of characters, in this case 6 characters. Then I'm going to be replacing it with a string of a certain size, so it's going to adjust the memory appropriately to begin with. Then it's going to end up moving in basically each of these different strings into that memory. And in this case here, it's going to see, oh, there's no characters, I have nothing to move, I'm not even going to copy anything over. So it doesn't bother copying over null terminating characters from this string. And that's important to remember because it does not cause your stuff to terminate early. Otherwise, stuff like this might cause it to terminate early. Some of the stuff where we were inserting space, for example, would cause it to terminate early if it ended up copying over null terminating characters. So it's important to remember that it doesn't do that even when you give it this sort of thing here. And this is how erase functions. Because if I undo that, and you can see down here how this would end up being, initially it would replace string, because originally this is not a test string, with banana phone. And then down here, you can see that it ends up erasing banana phone, as well as also this space right here. Because once again, you sort of have to count from here to then also the end for where you want it to be deleted and figure out how many characters that is. So that happens to be the general way in which you do that, and there are a few other ways in which you can do these variations on appending, replacing, inserting, and erasing. And we'll get into those in a couple of episodes when we get into what are known as iterators. But I'm going to cover iterators as one large bulk together, so I'm not going to get into those different overloads on these functions and methods now, just because that would be a bit more complex than what I'm looking to do. So there's one final thing I'm going to show you, and it's a relatively easy thing to do. And that happens to be that there is a version of appending and concatenation that takes place without modifying the original string. So you might remember that earlier on we had the plus equals operator. What you can also do, though, is you can also do the plus operator. So let's just say that we start off with smoon, and we want to add in that, and then add in, that's a space station. So that's a space station. Then what we can do with that, just toss on endl, if I do this correctly, endl, and you can see that this ends up working correctly. Alternatively, I could create a brand new string using these here and using this sort of plus, so I could basically go with something like string s equals that, but obviously it does not work for initializing it while I'm in the middle of doing this other stuff. But then if I run it, you can see down here it ends up outputting it correctly. And the important thing to note about the plus operator with strings is that it allows you to end up concatenating strings or appending one string onto another without modifying any of the strings that you are using in there. So that is its major difference between things such as append and this. So that's all for today. Spend a bit of time playing around with these, getting comfortable with them, getting used to the different overloads that there are for these methods. And I'll see you in the next episode, in which we will end up getting into a few of the remaining functions and methods that there are for strings. And then probably in a couple episodes, we'll get into iterators. Thank you very much for watching. Have a wonderful day.